Hello, this is Ms. DB, and in this lesson we're going to learn about properties of special parallelograms like rectangles, rhombuses, and squares. This is from Chapter 6, Section 4, and we'll learn all about rectangles, rhombuses, and squares and use those properties to solve problems. Alright, so here's our first one, is a rectangle. A rectangle is a quadrilateral with 4 right angles. That's the definition of rectangle. It has 4 right angles and it's a quadrilateral. We name it with the word rectangle and then the 4 vertices of the rectangle. So rectangle A, B, C, D is how you would call this. There's a couple theorems. They're very important. The first one says if a quadrilateral is a rectangle, then it is a parallelogram. So if you know it's a rectangle, then you also know it's a parallelogram. This is so important because if it's a parallelogram, then all of those many theorems that we learned about earlier in this chapter will still be true for the rectangle because it's a parallelogram. So that's a good thing. Also, if a parallelogram is a rectangle, so if you know it's a parallelogram and you know it's a rectangle, then its diagonals are congruent. This is not true of any parallelogram, but it is true if you have a parallelogram that's a rectangle. So if you have a rectangle, the diagonals will be congruent. That will also be very important. All right, let's look at a problem. We have a rectangular picture frame, and this is a JKLM, and it's a rectangle. It's given that it's rectangular, which means it's a rectangle, and they want us to know that JK, let me write that on, JK is 50 centimeters, and JL, that's the diagonal, is 86, so from here to here. They want us to find HM right here. Well, we know that because it's a rectangle, it's a parallelogram, and if it's a parallelogram that is a rectangle, then the diagonals are congruent. So JL is congruent to KM, which means that their lengths are equal. So that means that both of them are 86. Now we don't want KM, we only want HM. But because it's a parallelogram, we know that the diagonals bisect each other. That means that this piece is congruent to this piece. So if we can figure out what half of 86 is, then we'll know that HM is equal to 43 centimeters. Here's another example. We have this gate, and it's rectangular. That means it's a rectangle. We're given that. And it has diagonal braces. Well, because of theorem, what was the number on that one? Theorem 6.42, if a parallelogram is a rectangle, then its diagonals are congruent. Let me go back to the gate now. So that means that if, it looks like to me that this is just from L to J is 30.8. Well then, GJ would be twice as long as that because of it's a parallelogram and the diagonals bisect each other. So that L is the midpoint. And also HK will be congruent to GJ. That's really hard to say. GJ. Let's see how they set this up. And we might have to use right triangles here. Let's see. All right, so HJ is congruent to GK. Well, they wrote rectangle because it's a rectangle, the diagonals are congruent. But that's not why HJ is congruent to GK. That would be why HK, I'm going to rewrite this, would be congruent to JG. And then because they're congruent segments, definition of congruent segments, whoops, what's wrong with this thing? Oh, I'm sorry, I didn't see the part, this is 48. So this is 48 because it's a parallelogram. Not anything to do with diagonals though. And so opposite sides are congruent. And then we have, is that all they want us to find? Oh, that was it in that one. I thought it was going to get more complicated. And then it says it has diagonal braces. Now they want us to find HK. So here's what I was going to do earlier, in that you would have then that JL is congruent to LG because diagonals bisect each other, so L is the midpoint. So we know that the length of JL is equal to the length of LG, which is 61.6. And that's not what they wanted us to find. They want us to find HK, but HK is equal to JG. So it also will be 61.6. Okay, another special quadrilateral that we're learning about in this section is a rhombus. A rhombus is a quadrilateral with 4 congruent sides. You may have called them diamonds in the past, but their real name is a rhombus. So every side here is congruent to each other. Lots of theorems go along with rhombuses, lots of properties of rhombuses. First of all, if a quadrilateral is a rhombus, then it's a parallelogram, which means then that all the properties of parallelograms apply, like opposite sides are congruent and opposite sides are parallel and so on. If a parallelogram is a rhombus, then its diagonals are perpendicular. Only true in a rhombus, that the diagonals will be at right angles to each other. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. This is also important. That means that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Every one of these angles has been bisected. So like a rectangle, a rhombus is a parallelogram, so you can apply the properties of parallelograms to rhombuses, which will come in handy. Okay, in this problem, they want us to find TV, this side here. And what do we know? We know an angle, right in here is an angle. We also know an angle up here, but this is going to be the important part right here. This is 3b plus 4, and this side over here is 13b minus 9. They want us to find this side. But TV is equal to this one, and is equal to this one, and is equal to this one. They're all equal to each other. So maybe I can't find TV because I'm not given enough information, but I do know that XT is congruent to WV. So I could set those two things up equal to each other, plug in their expressions, 13b minus 9 equals 3b plus 4, and solve for b. So if I subtract 3b from both sides, minus 3b minus 3b, I'd get 10b minus 9 equals 4, and then I'll add 9 to both sides, and I'll get 10b equals 13, divide by 10, and you get b equals 1.3. Once you know what b is, you have to plug that back into either one of them, either this one or this one, and solve for a side. So it's the same answer. They get the same thing we do. And then so when you plug b in, you're going to get, wait, where'd it go? They started all over. There we go. 3 times 1.3 plus 4 is 7.9. So one side is XT is 7.9, but that's equal to the side TV because every side in a rhombus is the same. So the answer is 7.9. Now in this one, they're asking for a measure of an angle. So if you're looking for the measure of an angle, you're not going to use this, you're not going to use this. You're going to use the angle measures somehow. Now remember, this is important, in a rhombus and only in a rhombus, these diagonals will bisect each other at right angles. So 14a plus 20 is equal to 90 degrees because it's a right angle. And you can use that to find a, and then we can plug whatever we get into this to find angle VTZ, which is this angle here, but that's equal to this one because they're congruent to each other. So that's what we're going to start with. We're going to start by solving for a, using 14a plus 20 equals 90. Subtract 20 from both sides, and you get 14a equals 70. And then you divide both sides by 14 to get that a is equal to 5. Once you know what A is, you can plug that back in up here, and you'll have 5 times 5 is 25, minus 5 is 20. Now that's this angle, but these two angles are the same as each other because one of the other properties of rhombuses is that the angles are bisected by the diagonals. So we get 20 degrees, and then that's it for that problem. All right, here's another example of a rhombus. They want us to find side CD. So when you write two capital letters next to each other, it means find the length of that side. But I don't have any expressions for that side, but I do remember that in a rhombus, all the sides are congruent. So I can write that 5a equals 3a plus 17. Solve for a. Once I know that a is equal to, let's see, that would be minus 3a would be 2a equals 17. So a is 8.5, and then this will probably be easier to plug it in here. 5 times 8.5. Oh, they plugged it into the other one. That's okay, you can do either one. You should get the same thing either way. 42.5. And because that's this side, 42.5, but they're equal, all sides are the same as each other, so the other side is also 42.5. Length of CD, which is what we were looking for. This is also looking for, let's see, they want us to find a measure of an angle this time, so we don't need this information. What we do need to know in label is where are these angles. So the first one says measure of angle GCH. GCH, that's this angle right here. That's what we're looking for. And we are given that GCD, this whole angle is B plus 3 degrees. And CDF, this angle up here, is 6B minus 40. So we're given a lot of information, but not enough to find our the measure of the angle we're given yet. So what we need to do is remember that the measure of angle, where's GCD? GCD, this angle, plus CDF is 180 degrees. And the reason for that is because of one of the parallelogram properties that says that the consecutive angles will be supplementary. Because a rhombus is a parallelogram, so that means it follows the parallelogram theorems. So definition of rhombus, not such a great reason for this. This would be more, I can't write these too great, but parallelogram implies consecutive angles supplementary, maybe is the short way of saying it. And then we would plug in what we know. Okay, measure of angle GCD. GCD is given as B plus 3. Measure of angle CDF is 6B minus 40, and we'll solve this for B. So we'd get 7B minus 37 equals 180. Add 37 to both sides, and you'll have 7B equals 217. Divide both sides by 7 to get 31 degrees. That's B. Once you know what B is, we're going to plug it back in. Let's just plug it in here. So this would be 34 degrees. And they want to know what is GCH, which would be half of that. So half of 34 is 17. Whoops, we're at the answer there. So 17 degrees. All right, one more term for this section, and that is square. A square is a quadrilateral with 4 right angles and 4 congruent sides. That's the definition of square. So you'll need to show that a square is a parallelogram, a rectangle, and a rhombus, so it has the properties of all 3. Rhombuses, rectangles, and squares are sometimes referred to as special parallelograms. That's why we have that chapter, or that title, as that's the section. So we want to show first that the diagonals of square EFGH are congruent perpendicular bisectors of each other. So here's the diagonals. There's one that goes from here to here, and there's one that goes from here to here. So if it's a rectangle, they'll be congruent to each other. If it's a rhombus, they will intersect at right angles. They'll be perpendicular to each other. And also if it's a rhombus, they will bisect these angles. But I think we don't have to worry about that part. I think we just have to show that they're congruent and that they are perpendicular bisectors. So to do that, we are going to show that EG is congruent to FH, and let me put a point here, I don't know, P for the center, and that FP would be congruent to HP, and that EP would be congruent to PG, and also that the slopes of these two lines are opposite reciprocals of each other. Those are the things we have to figure out. So we need the midpoint of EG. And if the midpoint of EG is the same as the midpoint of FH, then we know that they are perpendicular, that they're bisectors of each other. So the midpoint from here to here would be, you take -4 plus 3 divided by 2 for the x-coordinate. That'd be -1/2. And then -1 plus 0 divided by 2, -1/2. So the midpoint is at -1/2, -1/2, right here. The midpoint of this line, F to H, would be -1 plus 0 divided by 2, and the y-coordinates would be 3 plus -4 divided by 2, which also is -1/2, -1/2. They have the same midpoint. So we know right from that that they bisect each other. This is congruent to this, and this is congruent to this. Now let's find the length of EG. So to find the length of EG, we'll use the distance formula, which says that you will take the difference in the x-coordinates and square it, and add to that the difference in the y-coordinates and square that. Okay, so we have, let's see, our x-coordinates are -4 and 3. -4 minus 3. That's -7, but we'll get to that. And then the y-coordinates is -1 plus or minus 0. Okay, so we have -7 squared, and then we have -1 squared, which is 49 plus 1, which is 50, so we get the square root of 50. And I could simplify that because that could be written as the square root of 25 times 2, so it would simplify to 5 square root of 2, but I don't think it matters too much. Now I'm going to take the distance of, let's see, that was EG of FH, and see if I get the same thing. So the distance from F to H is given by the distance formula, which I already wrote down right here, so I'm not going to write that all again. And I'll take, I'll start with F. -1 minus 0 would be -1 squared, and then 3 minus a -4 minus -4 is the same as 3 plus 4 squared. So I would have the square root of 1 squared, or -1 times -1 is 1. 3 plus 4 is 7, squared is 49. So I end up with the square root of 50 again, which again is equal to 5 square root of 2. So one more time, I get the same thing for each of them. So I know that the lengths are equal to each other. I know that they bisect each other. And then the last thing I really need to show is that they're perpendicular to each other. So I need to find the slope. The slope of EG is equal to the difference, so rise over run. So y minus y over x minus x. And you can do the little 2's and the little 1's if you want. So I'm going to take 0 minus a -1, that would be the same as 0 plus 1, which is 1, over 3 minus a -4, which is the same as 3 plus 4, which is 7. So I get a slope of 1/7 for EG. The slope of FH is equal to y minus y, so 3 minus a -4, that's the same as 3 plus 4, or 7, and then -1 minus 0 is -1. So the slope of FH is -7. So I've got one of the slopes is -7, the other one is +1/7, so the slopes are opposite reciprocals, so these lines are perpendicular to each other. So they're congruent perpendicular bisectors of each other. So as I click through here, you'll see the steps. They first show that they're congruent. They got the square root of 50 for both of them. Then we showed that they're perpendicular by finding the slopes. One was 1/7, one was -7. And then the last step was to show that they bisect each other by finding the midpoint of each of them. And since the midpoints were the same, that means they bisect each other. It doesn't matter in which order you do those three things, but those are the three things that we had to do. Okay, I'm not going to go through this example, which, oh no, this is different. I thought it was the same thing. So they have the vertices of a square given. They want you to show that the diagonals of the square are congruent perpendicular bisectors. Yeah, it is pretty much the same thing. So in this one, they don't give you a graph. I would say maybe graph it just for your own sake. And then we'll do the same thing. We'll find the distance between SV and TW. And in both of them, we got the square root of 122. The slope of SV they found to be 1/11. The slope of TW is -11, which means they're perpendicular. And then we got to find the midpoint of SV and TW. If the midpoints are the same, yes, we did that part already. If the midpoints are the same, then we have that they bisect each other. And they did find that they did, so therefore they are congruent perpendicular bisectors. All right, so here we have a rhombus, ABCD. E is the midpoint of AB, and F is the midpoint of CD. They want you to prove that AEFD, which is like the bottom half here, they want you to prove that that is a parallelogram. So if you take a rhombus and draw a line on opposite sides between the midpoint, you'll create a parallelogram. Here's the proof of this. It's not a kind of popping up one at a time thing. But first of all, they wrote the givens in. And second, they said that ABCD is a parallelogram because we know that if it's a rhombus, it's a parallelogram from the theorem in this chapter. Then we have that AE is parallel to FD. So these two segments would be parallel to each other because it's a parallelogram. Also, AB is congruent to CD because in a parallelogram, opposite sides are congruent. Also, that means that the length of AB is equal to the length of CD because of definition of congruence. All right, we are given that we had midpoints, so AE is half of AB and FD is half of CD because of definition of midpoint. We also can then use substitution because we know that, let's see, what are we substituting here? If FD is 1/2 of CD and CD is equal to AB, I can just substitute CD and AB for each other. So that's substitution. Well, if AB is equal to this, and, no, wait, maybe I have to do FD is equal to this. See, they're the same thing. So by the transitive property, you can say that AE is equal to FD. And that means that segment AE is congruent to segment FD because of definition of congruence, which then lets us know that this is a parallelogram because it's a quadrilateral. It's got 4 sides. It has one pair of opposite sides congruent. We just found that. And parallel, which we said right here. So therefore, it is a parallelogram. All right, so that's it for this section. Good luck on the worksheet. Please let me know if you have any questions. And just be sure to explain your answers as completely as you can.